Hi everybody, this is Dr. Nigro with another Chem Calculation Screencast. This one's going to focus on solubility and how to use solubility curves. All right, so solubility is a measurement of the maximum amount of a solute that can dissolve in a given amount of solvent. All right, so it's just a measure of how much stuff can dissolve in something else. All right, now that solubility is affected by a couple different environmental factors. All right, so it's affected by, all right, well, first of all, it's important to know the type of solute. All right, and by that I mean, is it polar or nonpolar? All right, it's also important to know the type of solvent. All right, and we determine these by looking at the intermolecular forces that are in play with these particular compounds. Remember, the key is like dissolves like. All right, so if something's polar, it tends to dissolve in other things that are polar. If something is nonpolar, it tends to dissolve in things that are non-polar. All right, in addition to the type of solvent and the type of solute, we also need to keep track of the temperature. All right, when we look at the curves in just a minute, you're going to see that the temperature greatly impacts the solubility, and it does so differently for a liquid versus a gas. So we need to know what state our solute is in as well. All right, and then finally, pressure can be important. All right, now we tend to deal with atmospheric pressure. We tend to form solutions with containers that are open to the atmosphere. But if you're trying to form a solution between a gas and a liquid, then pressure becomes very important. So pressure is important for the gases. All right. All right, and then the curves are going to give us some information about our solution. So the curve is going to tell us if our solution is saturated. All right, and that would be the exact amount that is able to dissolve in a particular amount of solvent. We could also have a solution that is unsaturated. All right, and if that's the case, then our solvent can dissolve more solute. It still has some space, quote unquote. All right, and then finally we have this weird state, which is super saturated, all right, where we have basically formed a solution, then cooled it to a lower temperature. And we've done so in a way that allows the extra solute to remain in solution, all right? And these solutions, when they're supersaturated, are very sensitive to external conditions. So if you, for example, drop an extra crystal of your solute in, it immediately can crash out. So all that extra solute might just spill right back out of solution, all right? They also are very sensitive to stirring. So if you stir them, if you just basically manipulate it in any way, all right, you can remove that extra solute and you go back to saturated versus super saturated. All right, so what do we do in terms of the curve? All right, so in general, I'm just going to look at NaNO3. All right, if you're above the curve, all right, then you are super saturated. All right, if you are below the curve, you are unsaturated. And if you're on the curve, you are saturated. All right. So this is a graph that has on our independent axis, our x-axis, we look at the temperature. So what temperature are we forming our solution? All right. And then on the y-axis is our dependent variable, which tells us the grams of solute that are able to dissolve within 100 grams of our solvent. And this particular set of solubility curves is all for H2O, water, being our solvent. All right, so we read this just like we do any other graph. We start with where we are in terms of temperature and then go up to the correct curve that goes with the compound we're interested in. All right, now we can also use it to determine which compounds are the least or the most soluble at a particular temperature. All right, for something that's the least soluble, it will have the lowest grams of solute per 100 grams of H2O. All right, and again, it's going to be the lowest. So if we look at 10 degrees, which is right here, the lowest curve I see is right here, which belongs to KClO3. So in this, particular instance, at 10 degrees Celsius, KClO3 is going to be the least soluble. All right, you can get maybe 5 grams of KClO3 within 100 grams of water at 10 degrees. All right, all the other compounds have values that are higher than that, which means they are more soluble at that temperature. All right, another type of question is like number 2, how many grams of KNO3 can be dissolved at 50 degrees Celsius? So let's say you wanted to prepare a solution. All right, a solubility chart is very handy. If you know the temperature, in this case 50 degrees, you can find your compound on the chart. This is KNO3, so we're right about here. And then you go over and look at the value for solubility. So this tells us that we could dissolve 80 grams of KNO3 in 100 grams of water if we are at 50 degrees Celsius. All right, so that's another use for our curve. All right, now I am going to be sliding the sheet up and down because I do have some, the chart's up at the top and some questions are down below. So just bear with me. All right, so a solution is comprised of 45 grams of NaNO3 in 100 grams of water at 30 degrees Celsius. And the question's asking, well, is that particular solution unsaturated, saturated, or supersaturated? All right, so we go look at 30 degrees and we're looking for sodium nitrate. So we follow all the way up to sodium nitrate. And we look, and to be saturated, I would need to be all the way up around 95 grams of NaNO3. All right, well, I only have 45 grams, so I'm actually well below my line. And if I'm below the line, then I am unsaturated. So I could continue to add NaNO3 to this solution, and it would continue to dissolve until I got to around 95 grams. All right. What mass of KNO3 will dissolve in 100 mils of water at 70 degrees Celsius? All right, now remember the density of water is basically 1 gram per milliliter. So if I have 100 milliliters, that's the same thing as 100 grams. All right, and that's exactly what's on our y-axis. So we're going to go look at 70 degrees Celsius for KNO3. There it is, way up there. And if we go over, it looks like around 130 grams of KNO3 will dissolve in 100 grams of H2O if we are at a temperature of 70 degrees Celsius. All right. For number 5, how many grams of KCl will dissolve in 250 grams of water at 80 degrees? All right. So this one is a little bit different. All right, we're not at 100 grams of water, so we can't use the map directly. All right, instead, we're going to set up a ratio. All right, the first thing, we're going to find the grams per 100 grams at 80 degrees off the chart, and then we're basically going to scale that up. I apologize for that. I'm in the high school, and it's, after school. All right, and we're going to scale that up. All right, to 250. So what does that mean? Well, the first thing we have to do is figure out, well, how many grams of our solute, KCl, could dissolve in 100 grams at 80 degrees? All right, again, I apologize. All right, so let's look. So we have KCl 80 degrees. So we're at 80 degrees. We're going to go up to KCl, which is right here. And it looks like we can get in about 50 grams. So 50 grams of KCl in 100 grams of H2O. All right, so instead of 100 grams, I have 250 grams of H2O. So how much of that KCl can I get in if I increase the amount of solvent? All right, so we're going to cross multiply here, and we're going to find that we can dissolve 125 grams of KCl if we are going to have 250 grams of that solvent. All right, so it's also a way to scale up or scale down. We could have done 50 grams of water instead of 250. We could have scaled it down. All right. Now, 6 says a mass of 80 grams of KNO3 is dissolved in 100 grams at 50 degrees. The solution is then heated to 70 degrees. So how many more grams of potassium nitrate do we need to add to make that solution saturated? All right, so we're going to start with the initial piece of information. 80 grams of KNO3 per 100 grams of H2O, and this is at 50 degrees Celsius. So let's go look for that on the graph. All right, so we're doing 50 degrees at KNO3. So here's our 50 again, KNO3. So we're right at saturated. All right, so now what we're going to do is heat our solution up to 70 degrees. So we're going to go to 70 degrees. Here's 70. All right, so by increasing that temperature, we drop from saturated to unsaturated, because to be saturated, we need to be all the way up here, which is around 130 grams. All right, so we're going to increase our temperature, and now we could have 130 grams of KNO3 per 100 grams of H2O. So if I look, 130 minus 80, I could add 50 more grams of potassium nitrate to my solution, and it should still dissolve. Okay? So these problems just give you an overview of the different types of questions that you can answer with a solubility chart. Important to note are the ratios, all right? We have a certain grams per 100, and that is a ratio. We can set that equal to scaling up or scaling down based on what the problem is asking. So please keep that in mind, all right? We can also have a saturated solution that we heat up, and we can calculate how much more substance can go in. We could also have the amount dissolved at a particular temperature, and we can decide whether that particular solution is saturated, unsaturated, or supersaturated. Okay? All right. I hope this has helped.